To set parameters for microdef PLCs, we need the microterminal program. First, we can open the microterminal by clicking on it from the Tools section. Alternatively, if you search for microterminal in the Start section, we can open the relevant application. We must connect the device via the USB port. We select the port and click Open. The screen turns green. Here we have many areas like GSM, socket status, PLC status, and a special command input. Let's start with Ethernet. In Ethernet, we have a section where we set the local IP's gateway and net mask. We can read the current IP by clicking Read. If we enter a value in the box and click Write, we perform the IP assignment. The device previously had the IP 10.186. We can change this by clicking Write. Gateway 10.1, net mask 255.255.0. Let's change this. If I set it to 10.185 and send the write command, I change the IP setting. Of course, the device needs to restart once for the parameter setting to take effect. DHCP mode means RTU automatically receives an IP. If you wanted to get an IP initially, you must send the DHCP1 command. Moving to the GSM side, if there is an APN setting related to an operator where you have inserted a SIM card, we enter this in the AT+ PERSAPN section. Here, when I say read, the internet is defined. I wrote MGBS. This time, when I say write, it will try to acquire an IP address with the defined APN address. If there is a GPRS name and password, we can write these in the relevant boxes. Here, the CSQ query is meaningful if the signal is 1, the lowest, and 31, the highest. @GPRS IP query is currently timing out. We need to query this after the GSM IP is acquired. First, we send a query to the connection area from the socket status section. The responses mean this: if 4 responses come from the connection query, the device is trying to get an IP. Here, of course, we need to have used the TCP socket block and slave block and selected the GSM media type. If the answer is 6, the device has acquired the GPRS IP. If it's 8, it means both IP is acquired and the connection is established. At stage 6, we can ask AT+ PERSAP and get a response at this stage. Let's move to the socket status section. Server timeout is set to 300. This means if communication breaks down between the remote system related to the device or the connection between devices breaks, wait for 300 seconds, and after 300 seconds, reset. It's the time we use to restart the communication. I said write 500. If communication breaks after 500 seconds, it resets the communication. AT+ PLCreset is used when the device freezes or in an extraordinary situation, to reset and restart. In the PLC status section, the help query teaches us what the queries inside the device mean and which ones we can ask. The AT+ include query tells us which features are active and which are not. We can also get a query about the memory status. If we want to learn the device version, we proceed with the AT+ version query, to 301 version 18.07, PCB version 71 is the device. The query where we get the serial number information of the device. AT+ power count was the query where we learned how many resets have been made since the start. The @error query tells us if the device is in an error state, if 0 then no error, and if there is, we learn the error code. In the PLC time section, the @SE time query is where we learn the date and time information inside. We can query by saying read. In the same format, we can take the set time section and change the date, time, values with the right command. Let's copy the relevant date and time here. Let's paste it back into the set time section and make an update. For example, let's adjust the date and time. We need to send the right command. Time offset adjustment is made in the @time offset section. In the Wi-Fi settings section, we enter the modem's password in the Wi-Fi passport, and the modem's name in the Wi-Fi SSID section. For example, we have a TP-Link modem. After defining this, we first enter the modem's name with a right-click command, and we define the password in our area just like. Similarly, we make the Internet IP, gateway, netmask in place. Here in the @Wi-Fi IP section, we can set the values in the Wi-Fi gateway and Wi-Fi netmask section. The device is currently returning an error response. But we defined an IP of 1.100. We have performed the IP assignments for the device with Wi-Fi by entering the gateway 192.168.1.1 with the right command. The CAN bus section is the area where the speeds and timeout durations between the PLC and its expansion module are determined. It is advised not to tamper with these areas. In the internal FS section, we have our @FPD command. FPD position is a query I use to read and write. For example, we will read the register value of 0 at address 3004. For this, we write the block number. If we ask with a question mark about this block, we learn its status. Or if we want to assign a value, especially we enter the value we will write with the block number. For example, if we write 10 at 3004, we are sending the value. Let's say @default, suppose we loaded a program in the wrong topology, and the device keeps resetting. We need to delete it due to this wrong design. By sending the @default equals 1 command, you can reset the software while the device is in this startup phase. By sending the @reset command with 1, you have the chance to restart the device. In such a case, instead of disconnecting the power, you can restart the device by sending @reset 1. For example, let's give this detail as we are currently connecting the device via the serial port. Since it is through one port, we cannot open the port from the microterminal. In the password assignment section, we set @T passport -1123. -1 became default, indicating that everyone is allowed to connect. We define the password. Right now, we assigned our password as 123 in the @password section. We just reset the device. We saw that the login was 0. We connected via the USB port to Telediagram, and this time the password query box appeared on the screen. When the correct password was applied, it said entry accepted and the first port in the lower left turned from a red lock to blue. Let's reconnect via the USB port. This time let's enter the wrong password. When we enter the wrong password, it said entry denied. In this way, if we try to load the project onto the device, no loading will occur. This will again ask for the password if we connect to the device via TCP/IP, similar to connecting via the USB cable. Therefore, with this encryption process, no intervention can be made to the device via USB cable or Ethernet TCP over GSM Wi-Fi. We have the opportunity to activate the login again by entering the password. We said at plus login 123. We activated the password. That is, we have made the connection. Suppose we will restore it to its old state or make password changes. Again, in a similar way, we write the current password, put a comma, write -1. If we reset the device, in the special command input, we can also get a response to a query we want to inquire about ourselves. For example, when I say at plus local IP equals a question mark, I get the response. In a similar way, if you are going to make an IP assignment again, when I say at plus local IP and send the relevant IP, I perform the IP assignment. Let's query again. The change in the IP address has been well displayed. Let's remind again. When we connect via the USB port through the Teledeogram program, when we open the relevant port on the microterminal, we see that the port cannot be opened. For this, we can use it in this way by closing the Teledeogram port and saying open the microterminal port.